And so let's just dive right into it. This webinar is really a deep dive in our new wall plate access point, which is the ECW 515. It's a Wi-Fi 7 access point designed to unlock in-room opportunity across MDU and hospitality, and I would say assisted living as well. So it could be student housing, senior living, apartments, hotels, resorts. And so in this session, what we'll be talking about is the technical spec of the ECW 515, the MDU related features, hospitality related features, and evaluating really 6 GHz for MDU and hospitality. And then we'll open it up for any questions that you may have. So hopefully the audio is still good. Let me know if that has changed as well. So again, my apologies for that. I'm not sure what happened there. Okay, let's get into it. Okay, in-room Wi-Fi 7 for apartments, condos, senior living, and assisted living. The benefits of the ECW 515 are it's a Wi-Fi 7 dual radio architecture, optimized antenna design. And by the way, yes, the benefits of Wi-Fi 7 do fall within 2.4 gigahertz and 5 gigahertz. We'll talk a little bit about that. It's up to 3.6 gigabits per second aggregate throughput. It's designed for up to about 1,000 square feet of in-room coverage. You might go a little bit further, depends on the propagation within the environment, but up to about 1,000 square feet, I feel safe with that. Supports 100 plus concurrent client devices per room or per device, I should say. It probably will support much more than that, but typically in like an MD or in hospitality, you're not doing more than that on a single access point. It's typically shared across multiple access points. This does have a 2.5 gigabit PoE plus uplink port, so you can actually place this 328 feet away from a PoE switch, a PoE adapter, whatever is within the configurations of the environment for multi-gigabit performance and simplified cabling. It does have an integrated 4-port gigabit switch for in-room wired connectivity, and we'll talk a little more about that as well. Okay, let's go a little bit deeper into the spec of this particular device. The ECW 515, here's different variances of or angles of the actual wall plate itself. Typically, I would show this on screen, but I don't have one in hand. They will be available very shortly, but it's 802.11be, which is Wi-Fi 7. It's a 2x2 radio design or antenna design, and it's dual radio. So it's operating on 5 gigahertz, which gives you 2.9 gigabit per second theoretical speeds, and on 2.4 gigahertz, it gives you 700 megabits per second. This does have a 5 dBi integrated omnidirectional antenna. You can find the antenna patterns on the datasheet, which is at ingeniustech.com. It's 5 dBi on 2.4 and 5 gigahertz. So the EIRP, let me slow it down a little bit, is 27 dBm on 5 gigahertz and 26 dBm, or not dBm, dB on 2.4 gigahertz. So if you're familiar with EIRP and that's something that you look at, it's 27 and 26. It does have adjustable radios. The 5 gigahertz is 22 dBm and the 2.4 gigahertz is 21 dBm. Typically in room Wi-Fi, you're trimming that output power down to suit the needs of these different environments, such as MDU and or in hospitality or assisted living. You're trying to keep the cell size the size of the room, or maybe just beyond the room. It just really depends. Again, it has one 2.5 gigabit PoE plus N with a built-in 4-port gigabit switch. And one of those ports is it provides power out, and we'll talk a little more about this. The 515 supports DFS on 5 gigahertz, obviously, if you're not familiar. So that gives you more channel options under 5 gigahertz. You can go as wide as 160 megahertz on this particular device. You can do 160, 80, 40, and 20. I would say in MDU in hospitality, you're typically going to use 40 and 20 with the number of channels that you'll be able to utilize at those channel widths. The AP does support AP and AP mesh mode. Typically, we don't suggest mesh mode. It's just not good practice. Best practice is all your devices are wired, but if you're in a predicament, then yes, use mesh mode in those scenarios. I would not mesh too many devices together personally. Um, the devices are TAA and NDA compliant. They're manufactured in Taiwan. That's where our manufacturing facilities is. This device has a 5-year factory warranty, which is above standard when you look at the competition, basically. And again, I apologize if there's background noise. There's actual construction happening in another room, and they just got louder. So, okay. So in regards to the ECW 515, it has a built-in 4-port gigabit switch, as I mentioned. Each port can be configured with either you can enable, disable the port. You can enable something called SSID on LAN, which I'll talk a little more about. You can tag and untag or bypass on these particular ports. You can actually create PVIDs, obviously, and then there's something called casting on LAN, which I'll also talk about. The port 2 is an optional uplink. Your primary uplink is the back port, which is the 2.5 gigabit port, and that's PoE plus. So you're going to need PoE plus to power this device up. That can happen on one of our gigabit or multi-gigabit switches. And then you do have an optional DC power. It does not come with the actual device, but you do have that option. LAN 5 provides power out, and that's up to 7 watts. So if you're trying to power a voice over IP phone in maybe student housing or maybe in hospitality, you do have that option with this particular device. And then we support a number of different things like 802.1q, SSID to VLAN tagging, crossband VLAN pass-through, management VLAN, PVID, as I mentioned. So there's a number of things that we do support on this particular device. I think there was a question around routing. This does not support routing protocols within it, but you can use items such as VIP service, which is you can find that within cloud under SSID configurations, or you can use firewall under the particular SSID configurations as well. If you're trying to share a particular port or a printer on this particular device, you can definitely do that. If you have multiple devices connected to this to these ports, you can share the printer with other devices within the room. So that is definitely optional for anybody interested in that. But no routing protocols. This is not a router whatsoever. It's an access point. Since the ECW 515 is a cloud-managed product, you can utilize the troubleshooting features available. So the diagnostics tools like CPU activity, memory usage, this is really helpful if you're trying to identify if there's an issue with the actual hardware itself. You can look at throughput per band. So I can look at throughput on 2.4 and 5 gigahertz. I can look at channel utilization per band. I can do speed test from the actual unit out to the internet to understand if the speed is okay from the physical unit. Maybe it's in a room in a particular room in the building on a floor. I can test speeds out to see, okay, is my wiring showing good? I can do ping test. I can ping inward towards a client device or outwards towards the internet or another device that's on the network that's down the chain. You can do packet capturing on the wireless side and the wired side, so some really advanced features that you can utilize. You have the all channel utilization per band, so this allows the device to do channel utilization within the area to understand, okay, am I using a clean channel or not, and should I change my channels? You can search and look at live clients that are actually connected to this device. And then you can also use client timeline, which tracks client devices exposure, it also tracks devices and an application analysis, which allows you to see the client and what the client is utilizing, what applications are running on the device itself. So there's a lot of diagnostic tools that support this device as well. So this is really helpful for MDU and hospitality. Okay, so let's look at some MDU specific features that you can utilize. So the wall plate itself is, it's purpose built for Wi-Fi within an area, a room. So if you think about a residential application, it's going to provide up to 1,000 square feet in residential, student housing, in hospitality. So it's giving you Wi-Fi 7 in these particular devices. This particular unit, or actually all our units, support now WPA3, which is the latest security, and WPA2 mixed mode with something called MyPSK, which is something really important for the MDU space specifically. And it can also be utilized in the hospitality space. This is actually a big deal, supporting WPA3 and MyPSK at the same time. Not a lot of vendors are doing this. There's maybe one other vendor that I'm aware of that's doing this. That's I would quote unquote call it an enterprise type vendor that's supporting this. We're providing WPA3, WPA2 mixed mode with MyPSK at a very aggressive price point on this particular access point and other access points. So this really delivers modern encryption, individual user credentials, and built-in segmentation without sacrificing any compatibility. So some of the benefits to that is seamless security transition. So like I said, it supports both WPA2 and WPA3, which WPA3 is the latest. So you have really it does this simultaneously. So you're really modernizing the security without breaking any legacy devices. Now you do have to be cautious with the legacy devices because those devices don't support everything that WPA3 supports, such as like protected management frames. So you have to be cautious with that. I just experienced that probably about a month ago in our office. We had a visitor come in and they could not connect to our network with their device because I had to disable protected management frames. Typically, you don't want to do that if you want to keep it secure, but just so you know. The other benefits to this is you have unique credentials per user. So MyPSK assigns a unique password per individual or device. So no more pre-shared keys. So when I walk into an office, I'm using one single pre-shared key. Everybody's using the same pre-shared key with MyPSK. It provides individual pre-shared keys for every user. You can actually revoke access for one user without impacting anyone. So if you want to take away privileges from a certain person, you can do that without affecting everybody. It has a built-in network. It comes with built-in network segmentation. So each MyPSK can be mapped to a specific VLAN. So that's enabling guest isolation, staff separation, IoT segmentation, compliant-friendly, really architecture, all under a single SSID. So my overall SSID is broadcasting Brian's network, but everybody's on a separate shared key and a VLAN as well. So very, very cool feature to use in MyPSK and also potentially in hospitality as well. This can be used with Radius or without Radius. We do have it built within our cloud system. So you can actually create per user credentials, VLAN assignments. You have stronger encryption without deploying 802.1x. Certificates are really complex Radius infrastructures, so it's perfect for lean IT teams. But you can move to a more advanced setup using Radius, where every user is dropped on a different VLAN. So that is utilized a lot within the MDU space. So you can do either or. So it's really a nice to have feature for the MDU space. You're really future-proofing encryption with backwards compatibility. Um, WPA3 really adds simultaneous authentication of equals, I would say, across different devices. Protection against brute force attacks, forward secrecy, mixed mode ensures like older WPA2 devices can still connect, which could reduce support calls and hardware replacement cost. Just keep in mind those management frames. If that's enabled, there are clients that don't support that. And Genius does something a little bit different than our competitors. We support up to 5,000 MyPSK users per network. So under an organization, you can have, under basic or actually under pro, you can have unlimited networks. I would say up to 500 networks, but 5,000 MyPSKs per network. So that's a lot. So you can break up MDUs by building, or they can all be under a single network. It really depends on the environment. Carrier grade Wi-Fi. So unlike unlike traditional voice over IP services, which require separate apps or platforms, Wi-Fi calling works really natively on mobile devices. I have it enabled on my iPhone, for example, and that automatically that this will automatically connect to carriers' networks via the internet. So when mobile devices are outside of a cellular network, you can utilize Wi-Fi to connect to the carrier's infrastructure. So it sets up a secure IPsec tunnel to what is called an EPDG server and continues the call seamlessly without dropping. So it's working with the IP multimedia subsystem and the evolved packet data gateway that the carrier is using. Is so when the phone connects to RAP and it's recognized as a carrier grade call, it makes a VPN IPsec tunnel between the device and the carrier, and then they can make the call out to the destination. So this really enhances reliability. So Wi-Fi calling connects to the carrier network through multiple channels, significantly reducing the likelihood of dropped calls and connectivity issues. So that's something that really you should keep in mind. And this really works well like in parking garages or campus grounds. Basically, where properties that don't have cellular coverage, you can utilize Wi-Fi to take advantage of the carrier grade Wi-Fi calling. It also improves the user experience. There's no additional apps required, so you're not opening up an additional app to make a call. This is all happening on the phone itself. It's very reliable. And offers high quality indoor calling. So when this system is set up, it does prioritize the packets, and you can set up that prioritization within the cloud interface. Okay, let's look at some hospitality specific features that you can utilize as well with this wall plate access point. So smart casting solutions, we have a whole suite of smart casting solutions. We have three. This is really built for bring your own entertainment across every hospitality environment. What I mean by that is a guest walks into a hotel room and they want to cast from their phone to the TV. How do they do that? Within Genius, we provide three different options, and it depends on the environment and I would say the IT group that's supporting it. So the first option is VLAN per room and something called SSID suffix, which I'll talk a little more about. But this is a per VLAN room based privacy focused network. So you get per room VLAN SSID. So that's maximum privacy. So you're basically using MyPSK, which allows same SSID with unique pre-shared keys and unique VLANs. So the guest is actually they're on their own pre-shared key in their own VLAN. Casting protocols work perfectly. So like MDNS and Bonjour, for example, work perfectly in this scenario. And again, this is room-based network isolation, which prevents cross-room casting interference. So if you're not aware, SmartCast solutions or smart casting within the hospitality industry has grown to a point where it's a must-have. And so we wanted to make sure we offered a number of different solutions for this. Another one is our SmartCast, which is where we started. SmartCast is a quick deployment with APs that are either in the hallways or in the guest rooms. In today's world, we suggest that the APs go into the guest rooms. That's best case scenario. If you're putting them in hallways, you're going to run into some interference issues. So you do want to get them into the rooms. But if you are in this situation where they're in the hallways, SmartCast is something that you can use. It's a QR code based casting feature. So it's balancing privacy and experience a little bit. There's no network changes needed. It's really a rapid rollout, I would say. It works properly under L2 isolation. You have a unified SSID across all rooms, and QR code driven device binding is happening on the back end. So hotel guest is the SSID, and it's working across that unified SSID very easily. But SmartCast is one of those options that you can use. The one that a lot of people are not aware of from Ingenious are really option number 1 and option number 3, casting on LAN. So this is really very specific. I would say 1 and 3, option 1 and 3 are very specific to the ECW 515. Casting on LAN is probably the best casting experience with simplified management. So you can local LAN cast, or local LAN casting, I should say. So casting traffic is confined to the AP within the room, so it's confined to the ECW 515. So that ensures room level privacy with no cross-room discovery. There's no QR code needed whatsoever, so it's the best user experience possible, and it works fine under L2 isolation. And again, because you're using SSID suffix, which I'll talk about on the next slide, it's dedicating the SSID per room. So we'll talk about that as well. But these are 3 options that can be used within hospitality. Arguably, it could be used probably within the MDU space as well. But these are 3 different ways that you can provide SmartCast to your hotel customers or guests. So these are things to consider. Okay, so let's talk about SSID suffix. This is something that we created, a feature that we added, I would say maybe 4 months ago. So this is simplify room specific SSIDs and VLAN configurations. So it provides a quick way to generate room specific SSIDs and VLANs. Basically, what we're trying to do is simplify large scale deployments and enhancing guest experiences and network isolation, really. How can SSID suffix really help? It's a quick setup for room specific SSID and VLANs. It's easy guest recognition of in-room Wi-Fi. The guest can see, for example, room 101 AP. They know I'm in room 101. There's an access point in room 101. There's an SSID with broadcasting room 101. I can connect to that particular SSID. This enables full room-based isolation with VLAN per room. It really streamlines the configuration for large-scale deployments, and it easily scales from unified Wi-Fi setup to room-specific SSIDs and VLANs. So what this allows you to do is create a SSID, and that SSID there's a subset SSID that can be created off a particular access point. So say I have 100 access points in a hotel. I'm looking at hotel room 102. So I'm in room 102. There's a access point within that room. I can create through the cloud interface, I can create a subset SSID called room 102 SSID, for example, and that will broadcast within the room and allow users to connect to that particular room. So this is something new that we added when we added LAN on SSID and a number of different things. So a very cool feature to be able to utilize within the hospitality space and potentially in MDU as well. Okay, so SSID on LAN, this is really in-room unified access. Some of the key benefits to this is really a consistent guest experience. So what this allows you to do, or allows your guests to do, is to plug into a port and they have the same experience if they connected Wi-Fi. So if I connect to a port on the ECW 515, I will get the captive portal authentication. I will get the splash page. So everything is very consistent. So this can happen on the wireless side or the wired side. So guests plugging into the room wall port receive the same captive portal, splash page, and authentication flow as a Wi-Fi user does. So no bypassing branding or terms when you plug into that wired port. So you have better brand control with the splash page that's basically everywhere. So you maintain the brand login pages, the promotions if there's promotions running, and you're upselling, loyalty program messaging, property announcements, even on the wire connection now. So this is a big deal that you can plug into the port of this particular device and have that same experience if you're doing it on the Wi-Fi side. You can enforce security and guest isolation. So wired guests are placed in the same VLAN as the wireless guest if they're on the VLAN. They're isolated from other rooms, protected with the same firewall and segmentation policies if you have that set up. And there's no unmanaged backdoor ports at this point. You can either disable or put them through this process of a portal and splash page. If you're doing like revenue and monetize optimization, such as using like GoZone Wireless, like tiered bandwidth packages, premium speed upgrades, event-based access, conference room billing, this can now apply to the Wi-Fi and the wired side. It eliminates rogue bypass access as well. So, in traditional in-room Ethernet ports, often bypass the captive portal. They skip the rate limiting. They avoid the terms acceptance process. So SSID on LAN, this particular feature closes that gap. So that's something to really keep in mind. It's just overall better experience for business travelers that are plugging in. Simplifies the IT operation as well. So there's a single authentication workflow, single VLAN policy. There's unified troubleshooting at this point, and this can all be centrally managed as well. And then you're also future-proofing for hybrid guest devices like smart TVs, streaming devices, conference equipment, maybe work from home hotel scenarios. So it's really all governed under one control access framework. So just keep that in mind as well. Oops. Yep. So I did want to talk about 6 gigahertz. And so the ECW 515 is a dual band access point. So it's operating on 2.4 and 5 gigahertz, and it's Wi-Fi 7. So Wi-Fi 7 can be utilized across 2.4, 5, and 6 gigahertz. You do see benefits, and we'll talk a little bit about that with 2.4 and 5 gigahertz, but also 6 gigahertz. So let's evaluate 6 gigahertz for MDU and hospitality environments. And Genius's focus is we're presenting a dual band Wi-Fi 7 wall plate. We do have on the roadmap a tri-band version of that, but let's first talk about why we did this, or maybe talk to why we did this. So when you're looking at, let's step back a little bit. When you're looking at Wi-Fi 6 versus Wi-Fi 7, we have two devices, the ECW 215 and the ECW 515. The ECW 215 is priced at the retail price is $149, and the ECW 515 is MSRP is $199. So there's some major advantages of the ECW 515. It's built for future proofing in high density environments. So Wi-Fi 7 performance, it doubles the theoretical throughput to 3.6 gigabits and supports 160 megahertz channels for lower latency. Now, we have to be honest here with with hospitality and MDU, you're not going to use 160 megahertz. But I know I do have customers on this call that go into the pro that do pro AV as well, and this becomes an entertainment hub. You can utilize 160 80 megahertz wide channels in residential if they're in rural, so you can get away with using those type or those wide bands. But in hospitality MDU, you're going to use 40 and 20. You have enhanced wired connectivity, so it features a 2.5 gigabit uplink to prevent any bottlenecks at the source and doubles the local Ethernet ports to 4, making it really ideal for connecting multiple in-room devices like smart TVs, voice over IP phones, and gaming consoles. It supports DFS. By supporting DFS, the ECW can access less congestion frequencies, which is really vital when you think about MDU and in hospitality, where it's crowded or you're in urban areas. You have more channels to use when you're deploying more of these devices. As I mentioned before, tenant features or guest features, both units include smart casting, SSID on LAN as an example, allowing users to really securely cast content to local TVs while also maintaining that enterprise-grade security. When to choose which, really. So I would choose the ECW 215 if you're looking for a cost-effective wall plate device that provides, gigabit speeds or gigabit speeds are sufficient. You're going to use the ECW 515 if you're deploying in high density areas because of the extra channels that you have on 5 gigahertz, and more ports are needed on the wired side. And if you want to take advantage of the Wi-Fi 7 standard and the performances on 2.4 and 5 gigahertz, this is where the 515 really shines. So you will see about a 10 to 20% performance gain with your current Wi-Fi 6 devices and even with your Wi-Fi 7 devices when you move to the 515. Your clients will see this. So I wanted to talk a little more about some testing that we've done, which is very interesting, and I thought I would share this. So some really interesting testing on Wi-Fi 7 AP testing, a 2x2 AP with multiple client devices. The chart shows Wi-Fi 7 5 gigahertz versus 6 gigahertz at different channel widths. Now we tested on 80 megahertz, 80 megahertz wide channels and 160 megahertz channels. Maybe I'll use my mouse a little bit to kind of show what's going on here. So if you look at scenario A, you're looking at Wi-Fi 5, or excuse me, Wi-Fi 7 on 5 gigahertz. Sorry about that. Channel 36. You have one client. RSSI is negative 40, which is very good signal strength. They're seeing about 932 megabits per second. Hopefully you can see my mouse. When another device jumps on, that device after A, that would be device B jumps on, you'll see that the speed drops to 465. So both devices have split the this total speed basically in half by 50 to 60%, somewhere around there. When 4 devices are online, again, we're at 80 megahertz. This is 5 gigahertz. Average speed is around I would say about 230, somewhere around there. So all the devices are splitting up the bandwidth of the single unit, basically. So what you're seeing is that the same airtime per radio is still shared between all the stations. So if you have one AP to one station, meaning one station being one client device, you get 100% of the bandwidth, which is 932. When the AP is communicating with 2 access points, and we're talking about 2x2 clients and 2x2 access points, the ECW 515 is a 2x2 access point right? So access points 2x2, the station is a 2x2. It cuts it by 50 to 60%. When the AP is communicating with three client devices or three stations, you're seeing about 35% of that total bandwidth. And then when you're going from one AP to four stations, you're seeing about 23%, 25% of the total throughput. And you can see this is true for 5 gigahertz, Wi-Fi 7 5 gigahertz at 80 megahertz wide channels, at 160 megahertz wide channels. And you can also see the same thing happening on 6 gigahertz at 80 and 160 megahertz wide channels. So very, really interesting information. And you also notice that the bandwidth, the total bandwidth with 6 gigahertz and 5 gigahertz is relatively the same. And in this case, you can see that 5 gigahertz is actually delivering faster speeds for this primary client. And when you get down to the individual levels, you see slightly faster speeds on the 5 gigahertz side. So the overall experience is slightly better in this scenario, right? And we're talking about 80 megahertz wide channels, right? On 160, it's very similar on a single device. You can see that you are close to 1.4 gigabit per second versus on 6 gigahertz, 1.2. You'll notice that the RSSIs are very, very similar. We try to keep them as clean as possible. And just to look at the devices that are connecting as they join, how the speed drops for the individual devices and how Wi-Fi 7 works on 6 gigahertz and 5 gigahertz. So very interesting information. With our testing, we back this up. We use Qualcomm, so we back our data up with Qualcomm's test reports, and this agrees with their conclusions as well. So very interesting data. I'm not sure if anybody's ever shared this, but this is testing that we did with a Wi-Fi 7 2x2 with client devices that are 2x2. And typically in today's world, you're going to see 2x2 clients on your networks. And so very, very interesting item to kind of take a look at. And what you should consider when you're deploying Wi-Fi 7 tri-band versus dual band operating on 2.4, 5 gigahertz, and 6 gigahertz. What are the benefits? And I think the real benefits we can talk about on this next slide is the things that you have to think about are building infrastructure, right? Are they running Cat5, which is maybe limiting it becomes a bottleneck. It's limiting it to 100 megabits per second. Does the building have to make an update to the cabling? Even if they're using Cat5e, that's going to restrict full multi-gigabit performance if you look at it very closely. Really, the standard right now, the gold standard, I would say, is Cat6a. That will help with future-proofing. I mean, you could even consider Cat7, I guess, in some cases. But there could be a cable infrastructure update that has to happen when you're thinking about 6 gigahertz. You also have to think about the ISP services that are coming into the building or into the hotel. What are they? Are they multi-gig level? Are they, are they a gigabit? Do they go beyond a gigabit? You have to think about that. You have to think about the switching fabric. Are they gigabit switches? Are they multi-gigabit switches? Are you tiering the bandwidth? So are you limiting the bandwidth already? Or can you utilize the 6 gigahertz within the building? You could be tiering the bandwidth per tenant or guest, so you have to consider that. 6 gigahertz, you have to be closer. You have to have closer AP placement. So for roaming purposes, if you're operating on 6 gigahertz, those APs have to be closer. 6 gigahertz, the signal propagation is shorter. It has a much harder time penetrating through walls, windows than 5 gigahertz and 2.4. When using 6 gigahertz, you have to have WPA3. You're using protected management frames as well when you're using WPA3 on 6 gigahertz. So you have to think about those devices that can support that. The major benefit I would say within the MDU space and the hospitality space is that you have more channels. You have more 80 megahertz wide channels, but because you're trimming the power down so much within the room, does it really make sense to use 6 gigahertz? I would question that a little bit. I would understand that and evaluate that. Then you have to think about the clients. The client devices that you have to utilize that are supporting 6 gigahertz cost anywhere from a baseline of $800 plus up to $1,500, depending on the device. If it's a smartphone, if it's a tablet, if it's a laptop or a desktop, those devices are more expensive. So you have to think about the clientele that are going into the building. If it's student housing, maybe they're not all using premium devices, maybe on their mobile phones, but maybe not on their laptops where they're doing most of their work. There's still a high concentration of Wi-Fi 5 and 6 devices out there that you have to support on your networks. Again, you have to consider the WPA3, the PMF. That's a major factor. Like I said, I experienced this a few months ago when we had a contractor in doing work on our building. They could not connect to our network because of the PMF or the protected management frames. I had to disable that function. The other factor is gaming consoles. I remember working on it was in private college, and they did a lot of gaming, and the consoles are using Wi-Fi 5 and Wi-Fi 6. I don't think there are any gaming consoles out there that are using Wi-Fi 7 or even 6 gigahertz yet. So that is a major factor, I would say, in student housing, MDU. And then the estimated 6 gigahertz usage in this market in MDU and hospitality is less than 20% of the clients. So you have to really consider the devices the access points that you install in these scenarios. So this is part of the reason we launched a dual band Wi-Fi 6, or excuse me, Wi-Fi 7 wall plate access point. We will follow it with a tri-band because this trend will change, but it's not changing fast enough. So we wanted to deliver a cost-effective Wi-Fi 7 wall plate access point for MDU, for hospitality, and assisted living. And I think that covers pretty much everything that I wanted to talk about today.